Hello everyone, the Extra Nodes version 3.0 is released with many new features, updates and fixes. So let's start with the new additions. I have added the growth system to the Extra Nodes. It is a curve-based growth. You can differentially grow the curve in 3D space as well as on any mesh surface. Because it is a system, so you can control the growth of the curve with the forces as well as with the Falloff Nodes. So let's quickly see its demo. We have this curve, then we can add the curve growth solver node. So if we run the simulation or the animation, see the curve is growing, but it is not differentially growing. So we have to increase the rate, maybe around 15. Okay, so let me first explain the settings and then I'll show you how to add the forces and other cool stuff. So in the general settings, you can define the fixed and continuous mode. Fixed is basically you can only input the curve at the start of the simulation. In the continuous mode, you can continuously add the curves during the simulation. So this is really a nice feature when you want to add the curve of different shapes or at different locations while simulating the growth. And after that you have the modes, 2D or 3D modes. So you can grow the curve in 3D as well as in the 2D. Right now it is growing in a plane because of this offset. So let's add the noise offset. So this offset allows you to define where to start the growth. Okay, so this is really handy feature. Let's make this a very small deviation to the curve. See, now it is 3D. Then you have the smooth option, so it will smooth the output curve. Okay, then you have the simulation settings. So here you can define the start and frame of the simulation as well as the substep. So if you increase the substep, it will improve the collision with the external object as well as the collision of these curves with themselves. And then you have the dynamic settings. So here you can define the length step, growth rate and other options. So the length step is basically the separation distance between the curve as well as their resampling length. Okay, so this length, suppose if I make this around 0.25, it will create a bigger these pattern. You can control the length step with this length factor. So this is really nice. Like you can input the Falloff nodes to control the behavior of the growth. So let me show you this. So if I add this curve edge Falloff node and then add the curve, let me pin this. So let's bring the curve here and let me show you the Falloff. So this is the Falloff. Then the growth will happen only where the Falloff greater than 0. See, it's like I'm moving along the curve. So with this feature, you can easily create a different patterns. Even you can also use a texture to create the pattern. Okay. Then you can control the rate, growth rate. If you set a higher value, it will grow faster. If you set a lower value, then growth will happen slowly and smoothly. Okay, then you have the smoothing option during the simulation. So this option will smooth the curve while doing the growth simulation. So let me make this 0. See, it is slightly chaotic. So if you make this around 1 or probably decrease the radius, then it will smooth the curve while simulating the growth. Then you have the force option. You can input any vector force and you can control the overall force effect with this force factor. So another update is that the forces that was only available in the particle system, now they are global. Means you can use them with any of the system that come with extra nodes as well as you can use them in your own system. Okay, so they are like global forces as we have in Blender. like these. So let's add the curve force, and let's select this curve, and we can plug that into the force. And let me first check the fall off. We're going to enable this for the radial strength, and also we're going to invert that maybe around 5, and this should be around 0.25. So if we run this, see, it is not spreading away from the curve. Now let's slightly decrease the radial strength and increase the tangent strength maybe around 0.5. See, the growth is happening, and also it is flowing along the curve. We can make the size slightly bigger, so we have a more pattern to the growth. Let me check we have to enable the smooth, so we have smooth curve, and this is really nice. You can easily add more curves to this, maybe here, something like that. Now it will grow along this circle. Okay, and one thing I forget is that suppose when this curve is growing, you can also reverse this. Means if you decrease the factor, it's going to smooth the curve. It's growing, then we can smooth that. Growing, and then you can smooth that. Okay, then you have the surface option to grow the curve onto any surface. So let's add maybe a icosphere, something like that. And then we have to also make it 3D because we want to grow in 3D space. And let's bring the sphere, connect that to geometry. You can also add the collection option, but here we're going to use the geometry. So let me go to the wireframe and see this. Yeah, it's not growing because we have to add the noise offset. The offset is really small, and we have to also decrease the step size because this is a 1 meter sphere. See, it is growing onto this sphere. You can add different forces with this. Let's maybe try a vertex force. So let's add that, change that to custom, and let's see. It is along the x-axis. So let me make this stronger. Yeah. Probably we can add a different axis. Okay, so there are a lot of options to play with this. So let me disable this and also make it 2D. And now let's try the collision. So you can also add the collision objects. So let's enable that, change that to geometry. Right now we are using the front side, the side of the surface that is facing the normal. Okay, see, the growth is not happening inside the sphere. You can also reverse that, change that to back side and make it slightly bigger so we can grow the curve inside the icosphere. Okay, and it can be 3D as well. Again, we have to add the noise offset V scale. See, it is growing inside this icosphere. So this is really nice to create a pattern that is like growing inside a mesh and then flowing into different parts of the object. Okay. You can also define the friction as well as the threshold distance from the collision surface. So this is the curve growth node, and it also comes with the curve info node, curve growth info node that provide the different attributes of the curve that you can use here in the geometry nodes, as well as you can store them and use them in the material. Let's talk about the another new updates, that is the XPBD physics. So I have added this XPBD based solver, that is the extended position based dynamics. This allows you to do the particle physics, grain physics, thread physics, cloth physics, and also the soft body physics. It has the solver node, the object, and then you have the utility nodes that are similar to the particle system, like you have the actions and you have the info nodes, then you have the instancer and separator, tracer, and also a constraint. So let's go to the geometry nodes. So let's add the solver node. Let's first talk about the settings of the solver node. Then I will demonstrate the XPBD physics for the particles. However, you can utilize this for different cases. I have kept the settings of this node similar to the particle system, so that will be easy for you to follow if you have the extra nodes. First, you can define the simulation settings, the start or end frame of the simulation, time step, as well as the sub steps. After that, you have the emission settings. You can do the duration based emission as well as the continuous. In the duration mode, you have another new option, that is the trigger. So this will allow you to trigger the emission of the particles. In continuous mode, you can control the density of the particles. However, in the duration mode, the density is can't be changed during the simulation. So now you can trigger the emission of the particles. And this option is also added to the particle system. In the emitter, you can input the geometry and also define the whether it is animated or not. So for the particle case, I have added another node, that is the KS distribute points on faces. So this is similar to the distribute points node, but it allows you to add the velocity component when this base mesh is animated. So you can enable this option here, animated, and plug this like this to the solver node. And here you can add the particles onto the surface as well as inside the mesh volume. Okay, so let's add a grid. So now we have these particles that are added to the solver. Okay, after that you have the particles properties. So you can define the attributes of the particles like life, size, mass, and other properties of the particles or the points of the geometry. Okay, and then you can also animate these attributes during a simulation. Like in this simulation, I animate the size of the particles. Then you have the dynamic settings. You can control the physics for the particles, like you can turn off the physics or you can enable the physics calculations for the particles. And here you can use this option to kill the particles and define the drag. And then you have the velocity factor, control the previous velocity scale of the particles. And then you have the force factor and force input. After that, you have the constraint option. Right now, I have provided only the single constraint, but in the coming version I will add more number of constraints to this node. Then you have the self collision for the particles. It has also a new option, that is the rotation. This is a rotation based on the self collision, like we have the rotation option in the surface collision. Then you have the surface collision. Then you have these three options that allow you to project the particles onto the curve, surface, and volume. In the curve, basically you can move the particles along the curve, like we have the follow curve force in Blender. But this option provide some flexibility over the duration as well as the velocity scales. So you can also add different forces to influence the particles while using this option. Okay. Then you can project the particles onto the surface, and you can also project the particle inside or outside of the mesh volume. So now let's see the demonstration of this. So if we run this, nothing happened because we haven't entered the force. So let's add the gravity. Yes, gravity, like this. Now you can add these forces. It provides the vector output. Okay, some points are falling under gravity. So right now all the points are visible, whether they are bound or not bound. Okay, you can use the separator node or you can use the instancer. So let's try the separator node. We want to only see the alive particles. See, you can also enable this, the unbound particles, and you can also add the instancer, XPBD instancer, to instance different objects onto these points. Okay, and the radius is really small, maybe around 4.5. Okay, So let me also show you the rotation. Let's add the turbulence force, maybe around 3 or 5. And we only want this in the XY plane. Now let's enable the self collision and also the rotation. And inside this node, we have to make this align factor 0 because we don't want the rotation based on the velocity. See they are rotating as they collide. So I use this feature in this apple example. So the apples are falling and they are rotating when they are self-colliding as well as with this bucket. You can also trace these points with the XPBD tracer node. Okay. In coming days, I'll make different tutorials related to this XPBD solver and how to utilize this in different scenarios. So this is the updates related to this XPBD physics solver. Now let's talk about the particle system. So this is the particle system. Now the forces section is moved outside this because they are now global. You can use them anywhere. So you have the collision section. It contains all the collision nodes like the particle based collision, surface hit and surface stick. And then you have the object system and the utility nodes. And another thing is that the store animation node, which was in the particle system, now it is in the general utility nodes because you can use them in the particle system as well as anywhere else. Okay, now let's talk about the updates related to this particle system. Let's add the particle system, plug that here, and let's go inside this. So if we run this, see the particles are falling under gravity. So there are a few changes to this particle system. So previously you can add the forces directly to this green line. But now you have to input the force to this node, that is particle system dynamic node. So like if you have let's say a turbulence force, you can combine them like this and then you can add them to the force input. In the advanced section, you can control the velocity factor. This is previous velocity scale of the particles. So this factor is important when you want to use the forces like a curl force, surface curl force or the field force. So this allows you to control whether you want to include the velocity, existing velocity of the particle while calculating the dynamics for the particle. And here you can control the selections for the particle as well as you can control the overall selection for the forces. Okay, so after this you have the collision section. So where you can add the collision nodes, these 4 collision nodes, you can add that here. Like we can add this node, this is the particle collision. Change that to size. Okay, and it also has this rotation option to add the particle collision based rotation to the particles. You can also add other collisions like a surface based collision and surface hit and surface stick. And for the case when the collision surface is animated, you have to use the store animation node. So in that case, you have to first input your geometry inside this node. It's going to store the animation and then you can input them to the surface collision node. And that is also true for other collisions like the surface hit or surface stick. Okay, there are also changes to the particle system node. I have added the kill option as well as the drag option. So here you can provide the selection to kill the particles and here you can add the drag to the particles. This is the internal drag. However, you have also a force, drag force that you can use. Okay, this one. And the follow curve option is now inbuilt. You can directly use this option when you want the particle should follow a curve. You can use this option and then you have the surface and the volume option. And there are also some changes to this particle system input node. The first is the trigger option. So now you can trigger the emission of the particles. Let me show you this. So let me first add the turbulence force, something like that, maybe 3 scale and 3 for the strength. Let's also decrease the particle size. Make this around 200 because initially we don't want any particle. And now let's add the KS object sphere Falloff node. Then we're going to add the empty. Let me pin this. So let's select the empty object and let's move them outside this. So we have no particles. So now let's run the simulation. So in this way, you can easily create a nice controlled emission of the particles. Okay, you can even create a different patterns based on the texture or based on other Falloff nodes. And in the emitter case, I have added the volume spacing option. So now you have two options to add the particles to the mesh volume based on the density as well as based on the volume spacing or volume grid option. And there are some name changes like these options only for the mesh surface. Second option is for the geometry. So you can input any geometry here, like you can input a curve circle. So you can emit the particles from the curve. Keep in mind that this option preserves the geometry elements. What I mean is that if I disable this option, see these curve points are still connected. Okay, and this is also true if you use the mesh geometry. So you can use this feature to create a really nice effect like I use this in this example. Okay. There are some other internal bug fixes and the performance improvement to this particle system. Now let's talk about the other updates. So there are new nodes for the curve. So now you have the curvature node. The curve helix is the old one. Then you have the curve rotation, curve to mesh, curve offset, offset point in curve, and then you have the set curve free normal. Curvature node provides the curvature for the curve. So let me resample that so that we have multiple points. See? And then you have the curve helix. It basically creates the helix from the curve. Then you have the curve rotation. So this is really important. Suppose you want to scatter some points based on the curve and you want to align them according to your tangent and normals of the curve. You don't need to add multiple nodes. Now you can use this option. It allows you to provide the rotations for the points. So you can plug this to align them according to the tangent of the curve, or you can align them along the normal of the curve. And there are other options like you can also lock the second axis of these instances. Like you can lock the second axis of these points and that will not change as you move or rotate the curve. Let me change that to none. So this is without the locking. See, there is some shift. See, now if we lock the second axis, suppose the x-axis, now they are perfectly aligned and they are pointing along the normal of the curve. So this is really handy. So after that, you have the curve to mesh node. It adds the profile to the curve. You can add the line, you can add the circle, or you can add your own custom profile to the curve. And here you can control the radius, the resolution, and you can also control the fill cap. This node also adds the UV map to the output mesh that you can utilize for the material. This is the offset curve. So you can offset the curve. Let me plug that here. This is really handy. You can offset any curve, whether it is cyclic or non-cyclic. Now let me trim this, thing like that. See? So now you can create really nice animations based on the curves. Then you have the offset point in the curve. Okay. Right now there are only 2 points. Let's add the more number of points. Maybe let's say 20. It's going to offset the points along the curve. So this is really handy when you want to use them for the instancing. Let me make this smaller. Okay. Then we have the set curve free normal node. So it will add a free normal to the curve that will not change when you translate or rotate the curve. So these are the new curve nodes. Now let's talk about the Falloff nodes. Now all the Falloff nodes have this advanced option. Okay, let me add another one that probably let's add also this one, then delay and the noise. Okay, this advanced option is available for all the Falloff nodes. In this case, like the curve edge Falloff node, it contains the radius as size or the radius as width. So basically you can use the radius of the curve for the size or for the width of the Falloff, and here you can control the smoothing of the Falloff. This is also available for, in this case, the mesh face Falloff node, and in the delay case it provides this option and also provide the control over the index that is being used for the delaying, and in case of noise it provides the position for the noise where it is sampling. So they are really handy features and they will save a lot of times while working with the motion graphics and other FX effects. And there is another update related to the memory Falloff node. Now it supports the vector values. So you can store the float values as well as the vector values. You can basically store a different color informations or a different vector information onto a geometry. So now let's talk about the field nodes. The field nodes are now simplified based on the new features of the geometry nodes. Now you have this really nice sample position option. So you can, by default, it is using the position option, but however, you can input your own custom positions to elevate the field. There is a big update to the curl field as well as there is a new node, the surface curl field. Okay. The curl field node is a general node. It can generate the curl field in 2D, in 3D, as well as on any mesh surface. And it used the exact method to calculate the curl field. However, the surface curl field node is optimized for the mesh surface and it is quite fast as compared to this while calculating the curl onto the mesh surface. But it needs a decent number of subdivisions for the surface. Okay, so while using this node, keep that in mind. The force section is already explained. There is a new force that is a surface curl force. It provides the force based on the surface curl. That is quite fast when you want to move the particles onto any surface and you want to use the curl force. So you can use this surface curl force that is optimized for the surface. There is another new node that is the force based on the curve curvature. And it is really handy while working with the growth system, the curve growth system. The mesh surface node now renamed as the surface force for the better clarity. Now let's talk about the scatter nodes. There is a new scatter node that is the disk scatter. It scatters the points in a disk. For the curve scatters like circle, curve, line or spiral, there is new option. Let me add them. These scatter nodes have a new option called the motion. This option allows you to move the instances along the curve. Let me make this smaller, something like that. Now if I enable this, you can move them along the curve. You can also loop them. And there is another option. Let me make them around 3. You can use the resampled curve. So you can create really nice this kind of animation. Okay, and this motion option is available for the circle scatter, curve scatter, line scatter, as well as for the spiral scatter. So there is also a new update related to the rotation alignment. So while working with the normal and tangent, you can align the instances along the one of the axis and you can also lock the other axis of the instances. So that is really important while translating or rotating these scatters as well as moving the points along the curve. Okay, so this option is available for all these curve based scatter nodes. Okay, there are also other UI changes that are done to these scatter nodes. Now let's talk about the tracer node. So let me add a field tracer modifier And let's add the field tracer node. Okay, I have converted this field tracer into a proper modifier. So now you can control the different settings of this from the modifier panel. General settings like density of the points, then iterations. You can control the field settings, this noise field. However, you can also use the different field nodes here. If you want to customize the behavior of this trace, then you can use this option, the surface, to only trace the field onto the surface. Then you have the geometry settings. Okay. In the iterations, you can trace the field in 2D, 3D, as well as you can trace its curl and surface curl. Okay. Like in this example, if I add more number of subdivisions, we get nice result on the surface curl based on this field. Okay. And similar modifier panels are added to the rest of these tracer nodes like geometry tracer, path tracer, and point tracer. Okay. Next is the utility nodes. There are new utility nodes that are added. So let me first add this one. This is from the particle system. Now it is a general node. Then you have the distribute points onto the faces that I have already explained. After that, you have the duplicate points node. So this is really handy. While working with the particle system. Like you can simulate a small number of particles and then you can duplicate them to create a large number of particles for the final scene. And after that, you have these three nodes: random integer, random value, and random vector. So this is really handy while working with the particles and motion graphics. So what they do is basically generate the random values based on the factor. Okay, you set the maximum value, then with this factor you can basically control the range for the minimum value. Okay, if you disable this normalize option, it can generate the negative values. So that is also true for this random values and random vectors. Okay, and the last is the volume cube node. So this node basically generate the volume based on the volume cube node, and you can define the size based on the geometry, as well as you can use these custom options. And here you can set different settings like the density, background, volume size, and this is the buffer size while using the geometry option. This is really handy if you want to create a different shapes with the Falloff nodes and with this option. So let's add the v2 mesh node. We have this. Now here we can add, let's say we can add this node, curve edge Falloff node, plug that into density, and let me pin this and add this curve, bring that here, plug this into the curve as well as to the geometry, and here we can make this 0.2. Let's increase the voxel size. So we have this shape based on the curve. Let's edit this curve. You can basically create this kind of shape. You can also smooth the geometry, go to the utility, add the smooth node. You can smooth the mesh, and you can also smooth the shading of this geometry. So you can easily create this stylized kind of things with this node. So this is the update related to the extra nodes version 3.0. I have also provided the change log. You can read that for the detailed information about the changes. If you have any doubt or query, you can ask me on my Discord channel, or you can ask me on my Patreon page, and all the project files are available on my Patreon page. I hope you like this update. Thank you for watching. See you in the next video. Happy noding. Bye.